Today we are going to take a peek at 8.6 and 8.7, some things with common logarithms and the number e. Some of this we've seen already. Okay. Common logarithms we've dealt with. It just means it's something with a plain log, which we know then is base 10. So when I start to do these, okay, if I've got something that's just base 10, I can type it into the calculator as such. If not, we've already talked several times about how I can use change of base to get to that particular solution. So I look and I'm like, okay, clear that other stuff out. Log of 18 divided by log of 6. And again, we're just going to the nearest hundredth here. And I get my answer. That even works if it's a decimal or a fraction that you're dealing with. So if I go out here to 3, for instance, I take the log of 76 divided by the log of 2.5. It's always size-wise larger divided by your base or your smaller value. And I can get to a solution. So decimals, fractions, you just keep running that same formula, we get to answers. Now, for the moment, we are going to skip by example 2 because I want to physically show you why in the daylights we would do some of these things, and I think it makes more sense once we've done this part right after it. But again, change of base is a good way to solve these if you don't have a 10 as your base. So when we get down here, it says solve each equation, round your answers to the nearest hundredth. Now we're going to start using all of those rules that we did before and all of those inverses. I need to get to x. The 7's in the way. I can't divide it out because the x is an exponent. How do I get the 7 out of there? Exponentiate. Nicely done. So, now, here's the thing though. When I'm using the logarithm to do the inverse, I'm not actually exponentiating. Because what happens is, this just becomes the log base 7 of 80. So, just like we just did up above, I'm going to go ahead and I'm going to use my change of base form. Log of 80 divided by log of 7. And notice now, again, we're still just rounding to the nearest hundredth. So I can get to my answer. Now, they might not necessarily always be quite that straightforward. Sometimes they will be. 6 still is. I need to get the 4 out of there. So I'll use the log of base 4 to accomplish that. Inverses take care of each other. That's good. Over here, I've got log base 4 of 100 plus 1. Now, there's a couple of things we got to be cautious of here. I've got to minus that 1 over. Not, though, to my logarithm. Don't turn this into log base 4 of 99. It doesn't work. Okay? So what I would do is I'd go ahead and do my logarithm first. So my log of 100 divided by my log of 4, except I've got to close my parenthesis. And then just subtract 1 from it. If you take it in pieces, you're less likely to run yourself into trouble. You're like, trouble? What's that? There's no trouble. 7. What's my first step going to be on 7? What log base am I going to be using? 3.6, because that's the side that has the variable term. So you're like, ooh. not so much ooh that there's decimals, but ooh, let's do all the other stuff before we get into all of this fancy business. So I'm going to add my 1 over. I'm going to try and save room because we're going to need it for 8 and 9 here. I'm just going to warn you. And then I'm going to divide by 4 to get my x. Now, this is one of those times for my speed demons who want to type it all in at once, you can get yourself into trouble. Because with all the parentheses that could be going on here, I need to keep my log separate from this. I need to keep this separate from the divided by 4. So, which is why I'm not going to do that. What I'm going to do instead is I'm going to just do this piece by piece in the calculator so I don't get myself into that bind with a bunch of double parentheses. If I do the log first, then add the 1, then divide by 4, that's going to get me into a much happier place than trying to punch it all in at once and get some really funky answer, and I'm itching my head trying to figure out where it came from. So once you get that x alone, do things in pieces with your log, and it will make life much, much easier than if you didn't.
What if you just didn't do it?
Oh.
Really?
So.
Really?
I have a question.
Okay.
Okay, 4x, like, are you, like, canceling it out?
Yeah, basically what I did, if I'd have taken one more step here, is I was basically just dividing both sides by 4. Yeah, and then that'll cancel. Yeah. Now, life is about to get interesting, so stay with me. So if some of you are speeding ahead and going to the homework, I would slow and come back for a minute, because this is going to get strange. We get to number 8, and you're like, okay, now we have an issue. There's x terms on both sides, and these numbers aren't the same. I cannot do log base 2 on this side and log base 3 on this side. It's like any equation. Whatever I do to one side, I have to do to both. So here's how we're going to handle this. We're not going to take a log of some other base. We're going to take a log of base 10. You're like, wait, what? Okay. We're going to flat log both of these sides, and I'll explain what we're up to here in a second. So if I cannot use the same base for both sides, we use our common log for this. And what I'm going to do once I've done this is I'm going to expand it, because I'm going to have to do some rearranging. So my first job is to take my exponents on both sides. When we're going to exponentiate, what happens? They come back and become coefficients. You're like, wait a minute, what? So x plus 5 times log of 2, excuse me, not base 2, equals x minus 2 log of 3. You're like, okay. We're not making much progress so far because now we still have all these x's here. So now what's the deal? Okay, next, I'm going to go ahead and I'm going to distribute that log through. We're going to expand a little bit more, and then we're going to start smashing back together here. So I've got x log of 2 plus 5 log of 2 equals x log of 3 minus 2 log of 3. And after this next step, trust me, it will make more sense. Oh, it's going to. Because remember, what in the big picture, what are we trying to do? We're trying to solve for x. To be able to solve for x, we have to have all the x's on the same side. So, my x term here is going to move to the left side. And this guy that doesn't have an x is coming back the other way. So, I'm going to leave this one here. I'm going to bring this one over, so I got to subtract it, because this is like a regular equation. And then over here, I've still got my negative 2 log 3, but I'm subtracting the 5 log 2 over. So all the x terms are now together on the same side. And you're like, yeah, and we're out of room too. We'll steal a little bit down here. Yeah. Okay. I will find a way to yammer some here so we can kind of take it in a little bit.
Is each one that looks like this going to be this much work?
Yes, but that's why there's not many of them. So
You mean like the
once we get my exponent to the front, distribute it, group my x terms together, what do these two terms have in common? They have x. So we factor that out. And we're actually almost done. So I get the x out of there, and notice now I no longer have 2 x terms, I have 1. Now the other side doesn't get to change yet because they don't have anything in common. So if you're trying to solve for x and you're multiplying it by these logs, divide it. Divide it by those logs. So finally, we're ready to try and get an answer. Now again, you're probably going to want to take this in pieces. Don't try to do this all at once because the number of parentheses you have would be ridiculous. Now luckily, it's just a common base. So all I got to do is negative 2 log 3 minus 5 log 2. So I get that first value. So now I'm going to divide by what I have left here. Again, I want parentheses because I want it divided by this whole quantity. So log 2 minus log of 3, and I do have to close that off with that second parenthesis because these are my outer ones now. Okay. There are very few problems where you get into this situation, but whenever those bases aren't the same or you're unfortunate enough to see x's on both sides, that is the way you have to tackle it. There's no other way of getting around it.
Can I just skip those?
You could, and then cross your fingers that one doesn't show up on a quiz or a test. So however you want to tackle that, you can. So, but that's how you would have to go after that. So again, don't stress out. There's not millions of them. There's just it's gonna take you a whole quiz to do that. Well, then I'd do the other questions first and save that one for the end. Okay. Now to something a little more straightforward and a little bit easier. Now that I've got some of you freaked out with that. Okay, on the other side, we get to do a little more dealings with E in natural log. We've talked about it, but we haven't really done a whole lot with it. So let's do some simple life. E and natural log are inverses. They wipe each other out, whatever's left in the exponent, your answer. You're like, that's nice. But the E and the natural log have to be right next to each other. In number 2, we can fix that though. We can just condense the exponent. This is really e to the natural log of 3 squared, otherwise known as e the natural log of 9. E and natural log cancel and just get me the value. So they have to be next to each other, but you're always going to have a way that you can manipulate it using your logarithm rules to be able to do that. Natural log and e, if they're just next to each other, that's cool. They're still inverses. It's just not exponentiated. So, it's kind of interesting, this one. Natural log and e are next to each other. This would normally just be 3, but normally just be 3, but you have a coefficient of 5 you're multiplying by. So that one doesn't get exponentiated. If I try to do that, I'm going to get myself in trouble.
Why are you multiplying?
Because if the whole problem were just the natural log of e to the third, the only thing that'd be left is the 3. So for this part, that natural log of e to the third would just be 3, but then you're multiplying that by 5 because that 5 was in front. So that's why I'm doing 5 times 3. I'm doing it in pieces. Ignore the 5 right now. If the 5 wasn't there, just like here, we got 9. The ln and e would cancel and leave me with the 9. Here, the ln and the e to the third would cancel, leaving me with 3. 3 times, there's a 5 in front, is all we're doing. And that's where the 15 would be coming from.
I thought it was like 5 times 3.
No, because that 5 wasn't brought up here. Again, this part right here is just 3, and I'm just timesing by what's there then. I've simplified this already. That's not an exponent anymore. It has been unexponentiated. I don't know if that's a word, but it's not. Well, write an equivalent exponential or logarithmic function. Okay. So if I were trying to solve this for x, what would I need to do? How do I get rid of the e?
Put it out.
You put an ln there. So x would equal natural log of 3. That is your logarithmic expression. So basically, you're just rewriting it as though you were solving it.
I don't think cancel out.
The ln and the e did.
Oh, you have to do it.
Yeah, whatever we do to one side, we've got to do to both, just like we would with any equation. If I have a natural log I need to get rid of, use the e, but that does exponentiate the other side. That would be my exponential equation. E to the x equals 15. Okay, I don't have to figure out what x is. I'm just rewriting it in its other format. So if it's natural log, we use e, and we're going to end up with some sort of exponential. And if I'm going the other route, if it's e, that's ln. And again, natural log does not exponentiate things. I'm not solving, I'm not doing anything else. Once I've got the natural log in here, I'm okay if I'm just writing an equivalent equation. Okay, not solving, not simplifying, just rewriting. And all the things that we've done with logs, we can also do with natural logs. Write as a single log. In other words, condense it. So again, when we're doing these, when we're condensing, coefficients turn back into exponents. And what does subtract become? Divide. So 3 to the third divided by 9 to the ninth, and that's going to be a ridiculously large number for 9 to the ninth, so we can just leave that way. For something smaller, we'd just go ahead and simplify, but that's kind of large. So we'll leave it. Again, coefficients become exponents. So I got the natural log of x squared plus the natural log of 4 squared, which is 16. And what does the plus become? Multiplication. So I got the natural log of 16x squared. And I work that out. Again, you can just do that in one step, or you could do it where you could go turn into an exponent and then turn the add into multiply. But yeah, you could do that in one step. So then down in the bottom, nothing as scary as 8/6 was. Solve by using the natural logarithmic functions. Round answers to the nearest 10,000th. So, okay. I just need to get this e out of there. Natural log it. So x is the natural log of 34. Let's see here. Natural log of 34. Nearest 10,000. 3.5264. But again, up here, remember, before you can use your inverse function, you have to have a clear path to it. I can't do ln here yet, can't do my natural log until that e is exposed. Once it is, then I can do the natural log.
Where's the twist?
Why are you thinking there's got to be a twist? Why is there got to be a twist every time? There doesn't have to be a twist every time.
But
Some observations occur over extended periods.
yeah,
I assume.
yeah, you know, it becomes a very good hypothesis.
Maybe. All right, let's see if I can find something that seems like more of a twist here.
Oh, no, you don't have to try.
Let's try 13 out here and see if we can get twisted. What do I need to do first on 13?
E both sides.
E both sides, because we need the natural log out of there. Okay. Now, I would not suggest at this point already punching in e and running to a decimal and rounding. Don't do it. What would be my next step? Okay, add the 2. And again, the 2 is not in the exponent. It's e to the 2.8 plus 2. And then what's my last step? Divide by 3. So when you go to figure this out, okay, so we've got second ln, there's my e. So 2.8, make sure you close your parenthesis. Here's a suggestion again. Plus 2, enter, divided by 3, enter. Because what's going to happen if you type it all in one big line? Let's see. 2.8
This will be the one time.
plus 2 divided by 3. What happened? Did the exponent first, e to the 2.8, but it didn't do the plus 2. It did 2 divided by 3 then and added that in. So no, bad. Don't want that. So either you're going to have to use parentheses, and again, the more parentheses some of you get, the more confusing this gets. I'd need a parenthesis here before the e, and here after the plus 2. You'd get the right answer, but again, I just do it in pieces, so I didn't have to even think about it. Just makes life simpler. One more up here, and then we're going to go talk about money.
You gonna give us any?
That would be nice. If I had extra money, I would, but life results just kind of.
Roll up to Harlem in the Lambo.
I just roll on up. So, okay.
Never mind, you were
16. Ooh, natural log and natural log. Okay. What's that add going to turn into?
Can't you just equal station?
Okay, I can't yet. I've got to get this condensed first, multiply those together, then I can go ahead and use my e.
That just seems like
I know that extra step is just like killer. Now, just like we did before, don't punch in your e yet. This is going to be the closest thing to a twist that I have. Square root it. Now again, I know, as usual, I have a suggestion. I would figure out what e squared divided by 2 is first, then square root it. here's where the fun begins. Ooh, it's a quadratic. Ooh, it's plus minus. But wait. Remember, can you take a log or a natural log of a negative value? No. Natural log of x. Natural log of negative 1.92. Oh, no. Okay. Be cautious.
You just want all Billy Mays.
You just want to be sure that whatever values you have, you're not creating that negative log or natural log in this case that you're trying to take.
That's when you say, but wait, there's no.
Well, there is. Wait, why did I square root it? How did I square it?
Like, yeah, the answers. Don't you have to round it first and then square?
No. I want to know what e to square divided by 2 is first. Okay? So then do square root and hit second. Let me bring this back up. And then get square root and hit second in the negative button, and it'll take the square root of your last answer.
That's so
I don't
exciting.
even know.
I will show you in a bit.
I wish I knew how to do that.
Oh, I don't know the answer.
I'll show you. So before we did principal, we did simple, we did compound, where we had all those different n values. Now we're going to compound continuously. You are making money on money, nonstop.
That sounds nice.
Doesn't it, though? So the formula for that, of course, has an e in it. So when we're trying to figure this out, p is what I start with, my principal. Okay. E, we know what e is. It's a value. My rate, again, has to be in decimal form, right? 0.04 times the number of years that I'm actually attempting to calculate it for. So about 1491.82 would be what I would have in that particular account. Now, the only other one down here I think we have to have is going to be 20, because I want to make sure we're thinking about this correctly, because otherwise it's just plugging numbers into a formula that you already have. How long will it take to double your money if you deposit $1,200 at an annual rate of 6.9% compounded continuously? Round your answer to the nearest whole number. In other words, like the nearest whole year. So, I deposit $1,200. My rate's 6.9%, which is 0.069. But it says how long, how much time, x, t, whatever variable you want to use here, right. So you're like, okay, so if it's time, I want to use y equals. So once I get that, and I get my chart up, and I'm like, okay, so what exactly am I looking for? Nice, okay? If I'm waiting to see how long it takes my money to double, I'm looking to see when y is greater than $2,400, because that's double my money. So I just roll down here, and it looks like it's going to take, I don't mind if you put 10 to 11 years, but since I said round to the whole number, I have to say 11. You're like, wait a minute. You said round to the nearest number. This is much closer than this. That's true, but is my money doubled at that point? No. So I have to go up to the next year, because otherwise I won't have double yet. So like I mentioned before, try and make life a little more reasonable here for some of you. Everything here now just strictly goes to evens. If there's individual numbers there that are odds, well, you get to whack those too.
Wow, that's fun. I like doing that.
So evens only, because again, you've got this. Tomorrow we'll be going through the quiz preview. I would at least take a peek at the quiz preview just to kind of see what I know and what I don't before I walk in tomorrow, and we'll talk about that then.